Welcome to this video tutorial on the topic of Primeprint Solution. In this video, we will demonstrate the workflow of creating a CEREC guide. We will run through the inLab CAD software up to the inLab CAM software. We start in the administration phase and select the indication CEREC Guide. Next, we click the appropriate tooth position in the odontogram to administrate a prosthetic planning element, and since these are oral scan data, we move to the next available phase, the model phase. In this phase, we can use the tools to make some modifications. In our case, we switch to the next step, Set Model Axis. The model axis is automatically suggested by the software. If necessary, modifications can be performed in the three views. The alignment is needed for the calculation of optimum initial proposals. Next, we proceed with the design phase. We review the inLab CAD software design proposal, which we can modify with the available tools if needed. Without making any changes, we go to the next step, Export/Import. In the window under Tools, we click the Export Planning Data button and select the appropriate storage location for the transfer of the planning data. By tapping Save, the data is saved in SIXD format so that it can be imported into the CCAT implant software. If you want to export to Galileo's implant, you have to select the format SSI via the drop-down menu. Since this video focuses on the workflow from the inLab CAD software up to the inLab CAM software, we skip the implant planning part in the CCAT implant software. Detailed information about implant planning is available in Part 2 of our tutorial series on the topic of Digital Chairside Implant Workflow. After concluding the planning, we import it into the inLab CAD software in CMG DXD format. After the import, we are automatically taken to the administration phase, where we can proceed with the CEREC guide planning. Before we switch to the design phase, we take a look at a more complex case involving implant planning with 4 implants in one jaw. With this case, device and material can be either selected for each individual CEREC guide, or several guides can be grouped into one guide, depending on the equipment. The software offers an automatic proposal for both options, taking into consideration overlaps between implant positions and observation of preparation angles based on the equipment type. This proposal can be adjusted for the implant positions with left and right clicks. For demonstration purposes, we modify the initial proposal and plan one guide for each quadrant. With a right click, the implant positions can be deleted from the current guide. With a left click, a new CEREC guide can be created for the selected implant position, or the implant position can be added to a different guide. Now, 2 guides that can be designed separately are displayed under Case Details. We now proceed with our original case. After switching to the model phase, an initial design proposal is displayed. In our case, we are planning a CEREC Guide 3. The design workflow for a CEREC Guide 2 is the same. The surgical guide includes 2 adjacent teeth, mesial and distal respectively, if present. Before we proceed with the tools, just for demonstration purposes, we go back to the CEREC Guide parameter step. There are 2 parameters that can be adjusted individually. The thickness parameter is marked with a lock, indicating that the 2 mm are a manufacturer recommendation, but it can be modified at your own risk. A thicker guide will be stiffer and less flexible. Adjusting the spacer determines how tightly the guide will be sitting in the patient's mouth. A reduction of the spacer leads to a tighter seat of the guide. By raising the spacer, it will be easier to place and remove the guide. In our case, we skip all adjustments and go to the Edit CEREC Guide step. The surgical guide sleeve is colored in red, as can be easily seen. Because this is a warning indicating a narrow situation, we will come back to it later in the video. First of all, we enable the Adapt Seating Area tool. Here, three options are available. The option Select allows you to mark complete areas and lengthen or shorten the surgical guide seating area. For our demonstration, we extend in the mesial direction. Starting at the surgical guide, we mark the area to be lengthened by holding the left mouse button down. By tapping Apply, the surgical guide is extended. We switch to the last option, Remove. This tool allows you to remove areas in a circular manner. The radius can additionally be adjusted with the slider. For demonstration purposes, we will slightly reduce the surgical guide. By confirming with Apply, the guide was shortened by this area. Next, we switch to the Adapt Support Geometry tool. The slider allows you to decrease or increase the support geometry radius. As an alternative, we tap the support geometry and can then make modifications by dragging the mouse. The last tool in this step allows you to place inspection windows. To begin with, we place two windows proximal to the surgical guide sleeve, respectively. This can be of advantage in narrow spaces. In our case, this has made the warning disappear. An additional window in the premolar area helps with checking the final seat of the surgical guide in the patient's mouth. Now we move on to the next step, Finalize. Again, there are three tools available here. With the Form tool, you have the option of adding, smoothing, or removing material in certain areas of the surgical guide. The size and strength of the tool can be adjusted using the sliders. We move on with the next option, Cut. This tool allows for final shortening of the surgical guide. For demonstration purposes, we place a centered cutting edge on one of the front teeth. We start with a double click and place the cutting edge with an additional double click. This cutting edge provides another opportunity to review the final position of the surgical guide inside the patient's mouth. When enabling the third tool, it is possible to have the guide recalculated if necessary. Before moving to the last phase, the export phase, we will look at another CEREC guide case with multiple implant positions. This is a case involving a more complex implant planning, with 4 implants in the lower jaw, which we showed at the beginning in the administration phase. The implants can either be printed with one surgical guide that serves for all implant positions, or you can design 2 surgical guides, for example. Now we proceed with our first case in the export phase. In this phase, we look at our surgical guide again and have selected the option Export to inLab CAM to transmit the surgical guide. A message confirming the successful export will be displayed. After the inLab CAM software is opened, all cases previously transmitted are displayed and the CEREC guide job is already selected. Here we can either select the so-called Fast Track by tapping the double arrow, or we can switch to the next phase, the Arrange phase. Fast Track will take you directly to the last phase, Produce. In this case, the inLab CAM software automatically positions and orients the print object on the build platform and also defines the support structure automatically. Detailed information about the inLab CAM software can be found in a different video tutorial. We click on the double arrow and can finally modify the detail level in the window under Production Options and analyze the print object with the Analyzing tools. To start printing, we tap the green area labeled Start Production. Thank you very much for your attention. We would like to wish you every success when working with Primeprint Solution.